Hi, and welcome to this short video where I'm going to just talk through the Teacher Pack 2 for the ENGINmakers materials that we've created. So you can see I've got a little robot down here. So this project involves getting the pupils to design code to remotely control a microbit robot with another microbit. So I'll just get that robot. The one that we've got here is a Move Mini, which is made by Kitronic, and there are lots of different microbit robots available, and I'd actually like to be able to supply code that would work with different ones. The ones that we have in the teacher pack is actually a slightly different one, and because of we had more of those available to borrow for the day that we did it, and would happily help you to create the code to work on your specific robot if you're having trouble with that, because the brain code that goes on the robot itself is slightly more complicated. We don't get the pupils to do that themselves, but they can push the code on, and the kind of tricky bit is hidden inside a function, which they can look into if they want to, but it has more different cases to handle to be able to work well for the examples we wanted to use. So this robot is on and ready, and so then I've got controller number 1 here. So the first exercise involves a digital control, and so then we can program the buttons so that the button A should turn the robot left for a certain amount of time, button B turns the robot right for a certain amount of time, and if we press both buttons, should drive forwards. So it is possible to drive in this way, but it's quite tricky to get exactly where you want to go around this obstacle. Oh, I've hit it. But you get the idea of how I can control it with this. And then you can add to that by having gestures here that would activate a series of commands. So I've got one gesture is to touch the logo. So if I touch the microbit logo, it's going to do a series of movements. And if I shake the microbit, then it activates a different series. And we've nearly lost our robot there, but hopefully I'll be able to get it back with the other controller. So that's the first part with the digital controller. I'll turn this one off so that it doesn't interfere with the other one, which has like now the final code that we could aim for at the end of the whole teaching experience. This one is loaded up so that then if I press button A, now I actually have a controller which is able to send the pitch, so moving the microbit in this direction, pitching up and down, or roll left and right, so that I can drive the microbit. And you can see that actually with this, I've got quite a lot of precision in how I swing it around. And if I have an additional attachment like the grabber that you can see on this particular robot, then we could control that as well. So if I press button B and then lean the microbit forwards and backwards, I can control the grabber, and then hopefully I can just drive into position here. I got it wrong there. So then I need to go back the other way and then close the grabber, and then, not quite. So I'll just try one more time here. I might need to look down rather than using my remote view that I can see at the moment on the screen. Oh, that looks like it's got it. Come on. Oh, I didn't quite have it. But you can see that I've got the control, which is actually quite responsive. And I find this really compelling that we can get a pretty good analog remote controller out of just having 2 microbits. And obviously we need a microbit robot, and do get in contact if you come across a microbit robot that you'd like to get brain code for. And I hope you have fun and that your pupils learn something from doing an exercise like this. Thanks. Bye.